All right. So let us begin. So
Yes, sir.
yeah.
In an isosceles triangle ABC.
So this is 2016 question number.
Yes.
Do
Two.
you two? Okay. All right. So in an isosceles triangle ABC, so I'm drawing the triangle. Okay. Then.
AB is equal to AC.
Mm-hmm.
The bisector AD of angle A
Okay.
meets the side BC at D.
Okay.
The line perpendicular to AD through D meets AB at F.
The line perpendicular to D.
The line perpendicular to AD through D.
Okay.
Meets AB at F.
But it will be this line only, right? DB. The line perpendicular to AD at D. So what am I doing wrong?
Sir, I was also confused about this part.
Okay. Okay, but go on. Let's see. The meets.
Meets AB at F and AC produced at E.
Okay, let's take it like this. Okay, let's imagine that maybe they want to. So AB is equal to AC, and the bisector is of A. You are sure about that?
Yes.
Okay. Then the line perpendicular to D doesn't make sense. No, it doesn't make any sense. And even this one will not make sense because then, yeah, then why not perpendicular to AC? So can you say that last line again? The line through D.
The line perpendicular to AD through D meets AB at F and AC produced at E.
Then we cannot discriminate between AB and AC also, right? So the question doesn't make sense. Like I'm not able to interpret it also in a different way. So let's leave this question. Okay. Yeah, let's try to do some other question. If someone has another interpretation, then they can say. If no, then let's move on. So yeah, Ishana, you should ask one more question if there is any.
Yes, sir. If A, B, C are positive reals,
Okay, and question number?
so on,
Oh, positive reals. Okay.
and A plus B plus C is 50,
Mm-hmm.
and 3A plus B minus C is 70. If X is equal to 5A plus 4B plus 2C,
Mm-hmm.
find the range of the values of X.
Right. Range of X. Okay. All right. So how do we do this? So one way that I can think of, so I'm going to say right away what I think of, and you can also tell me. All of you who are looking at this question can tell me. Okay. Can we simplify 3b plus c? We can. Can you say? So the idea is that you have two equations and three variables. So you can solve for two of the variables in terms of the third variable, right? That should be the logic. That's one way I'm seeing.
Sir, I had done that and I found that the x can be at max 210.
Okay. And so if you solved it, then you can say, or let us solve it and then you can. So you solved which one in terms of which one?
I solved a and b in terms of c.
In terms of c, right? So c was like your free variable. Okay. So let
Yes.
us also solve and then you can match it. So how do we do this, right? So maybe just we'll try to eliminate. So multiply this by 3 and subtract. So I'm leaving the first one as it is, multiplying by 3 and subtracting. Minus 2b minus 4c 70 minus 80. Then I'll multiply this by half, add it here. So I'll again copy the first equation. No, first equation is going to change now. This, no, yes, it is fine. Minus c plus 10. Okay. So obviously you can just solve it now, but I just want to say write it systematically just for the. Because actually, this turns out to be a very profound piece of mathematics that we are doing. It's a very simple thing, but this is the foundation of something very deep. But we will just write it systematically. And for us, then b becomes 40 minus 2c. And this is all we will need because a we have already eliminated by this simple stuff. So b is 40 minus 2c and also a is 10 plus c. The point is that I knew that I can do it. I knew that I can solve for a and b in terms of c. Okay. And then doing it is easy, but also we read it systematically. So the b is 40 minus 2c. So 3b is 120 minus 6c plus c. And this. So is this the 210? I'm not getting 210, but I'm getting 290. So has everybody checked? Is this correct? Is the calculation correct?
Yes, sir. I got.
You got
So
that,
the
okay.
calculation is correct, but in the x part we have written 2 into a plus b plus c. So together we get 6b, right?
No, it's 2a plus 3a, so that's 5a.
Yes, but for the b it's coming 6b.
Okay, so that's wrong. So this should be 2. Yeah, I invariably make these mistakes. I don't know why. So this b plus c. So change this. So we don't need this. Yeah. So certainly x is less than 210, that's correct. Now the question is, how small can this be? That is the problem.
C can maximum be 48
No, that is not correct. Why?
because if A and B are 1, because they're positive reals.
No, but they are positive reals, right? They are not positive naturals.
Oh, yes.
Yeah. So this is like we are looking for positive solutions.
C is definitely less than 20
C is less than 20. Why? Why?
because B is 40 minus 2C and it's positive.
Right. So this implies that C is less than 20. So then I think you can just put C equal to 20 and see if you get a positive solution, right? Right. So that's your extreme case, and you can just check if it gives a positive solution. And I think it does. Right. This should give positive solution, or yeah.
A is 30 then.
Then B becomes 0. Yeah, so that is fine, right? A is so like how to say this? So you can say that A is like less than 30 and B is greater than 0 and C is less than 20. Kind of. Yes, I don't think this is a problem, right? So basically that's so you can just say, right, that given any number, I can take A to be this and I can take B to be this. Means any, so it won't work for 0 when that epsilon is 0. It won't work for that because then if B becomes 0, that's not possible. But you can take this and you can take C to be 20. So then what should C be? 20 maybe this was 2, right? No, 20 minus epsilon and 2 epsilon. Yeah, this one is okay, right? Adds up to, yeah, adds up. This satisfies the equations, right? Okay, then it works. So this means that C can be anything less than 20, right? Because it gives us solutions. Is that fine? So it's like we won't get a strict, of course, that we were not getting anyways. Even the upper bound is not strict. Even means we will get strict. Even the upper bound, the equality cannot hold because C is positive. But yeah. So C is less than 20, so this is greater than 190. Yeah, this reasoning I've done precisely, but you don't have to do it precisely. You can just see, okay, C is slightly less than 20. So I was getting B equal to 0 when I put C equal to 20. So I make C slightly less than 20 and make B slightly bigger than 0. And they balance out, and then that's fine. Right? I mean, you can even just forget this and write like this. Probably this also works. Okay, and you can put it in the other equation also and see that it will work. Probably. Does it work? More or less. So this is like 90 plus, yeah, but that's not a good piece of reasoning. More or less kind of thing is plus epsilon. And this is what we intended. But then this becomes 2 epsilon. So that is a problem. Yeah. So we have to find a proper explanation for this now. So let me see. Because it has to satisfy both the, like roughly you understand that this is the correct answer, I suppose. But so what you have to then do, okay, so C is 20 minus 2, C is less than 20. So you want to say that C can be anything less than 20. That is what the intuition is. So in order to make that precise, you say, okay, I will say take C to be this, and let me see if I can now solve for A and B positively. Let us see if we can do it. So if C is equal to this, then what do we get? We have already actually written down the equations here, written down the solution, so we don't have to solve it again. 40 minus 2 this. So how much is this? This is 2 epsilon, right? And how much is A? 10 plus 20 minus epsilon, so it is 30 minus epsilon. And all three are positive, so this is the solution. Now there is no controversy.
Yes.
Right? Okay. This is like a technique which maybe you have not thought about earlier. So this is a technique which I'm telling. Okay, and now you can understand that it only makes sense, right? This is how you should do. Otherwise, because what does it mean to say something is less than something? It means that for any small number, there is a gap. So in order to say that C is less than 20, what does this even mean? This means that C can be, it means that given any epsilon, C is equal to 20, C can attain the value 20 minus epsilon. Given any epsilon greater than 0, no matter how small it is, C can attain this value. What does it mean to say C can attain this value? It means that for this value of C, there will be a solution which will be legal. Okay, so that is it. You can even make variations in this question. Like if they said, okay, A is bigger than 1, B is bigger than 2, C is bigger than 3, then you can just shift the variables, right? If they say A is bigger than 1, then you will say, okay, I will use this variable A prime. You substitute and then you reduce the problem to this. Okay, so these are the techniques. Yeah. There should be better ways to there is still a problem in means that we found a solution, but maybe you still find something unsatisfying, not in the explanation, I suppose, because the solution is fine, but in the method, in the sense that it looks a little ad hoc. Right, like we have solved for B and we have solved for A, and these are functions of, okay, and so how do I say this? Well, I want to say it properly because yeah, I did say that we'll solve it quickly, but as it always happens, maybe this is how we learn a little bit. So let me erase a few things. so that I can say the matter, because there is some matter here, and this goes into very nice problem solving techniques called linear programming. Well, some of it is there in the syllabus also, says CBSE syllabus at least. But what I'm trying to say is that see, you have one equation, you have two equations, and you have one thing which you want to minimize or maximize. Minimize and maximize actually. Okay. So one thing you can understand is that this greater than or greater than equal to, those are not important issues. Okay, so you can assume it's greater than equal to, and you can then focus on finding maximum and minimum of this system. Okay. Now, if this was not there, this condition was not there, then the problem becomes trivial. Why? Because once you find this, then you know that C can actually take any value. That is one beautiful thing, right? The linear equations are very straight, sharp things, like in the sense that in this way or that way. So once you find this, that B is equal to this, A is equal to this, C can actually take any value, any real value you put for C, the other two values are determined. So then the maximum minimum is okay, minimum is 0. Okay, so that is fine. But the moment this condition comes, and as I have explained, this is like the only condition. Any other condition of this nature, in a sense that A is bigger than or equal to 2, B is bigger than or equal to 3, those can be transformed to this. So in principle, this is like the only question, kind of. Okay, as long as we have linear equations and linear function that we want to maximize or minimize. Okay, in calculus you have like one variable function and you want to maximize it, minimize it. But here there is situation is different. There is a 3 variable function and we have lots of conditions. So I myself don't know this properly. I've studied this at one point, but what I can tell you now is let's think of a systematic way to do this. Okay, so given these two, let's assume that there is only one more variable than number of constraints, number of equations, and only one more variable. So the point is that in the end, you will always be able to solve them like this, right? So let's see. So let's forget this thing for a minute. Let's try to understand this. Yes. So let us imagine that given these two kind of equations, you can always solve them like this, which you cannot always actually. So I was wrong there. But most in the non-degenerate, in the good case, general cases, you can solve them. Okay. So once you solve them like this, that also means that this actually just becomes a function in one variable. This will also just become a function in C. Do you agree? So how will it become? It will become some A plus BC. Okay, for the sake of simplicity, it will be like, let's say it becomes some 100 plus 200, whatever, 5C. You understand it. The point is that it will be just a function in C and nothing else. Okay, so you only have a function in C, and here also you will have two functions in C, right? This will also just be something, some number times, some linear thing in C. So what we have here in general, it will be, how will it be? It will be like A1 plus B1. Okay, maybe that's a little confusing, A1, B1. So maybe C1 plus D1C, right? And C2 plus D2C. This is how you will always solve them. And then what do you have to obey? You have to just obey that these are positive. So now you see, you have two, so A and B are out of the picture completely. That's the first thing. Okay? You have a function which is linear in C, and you have to find its maximum minimum, and you have two equations like this, two inequalities like this, which are also only in C. So how will you solve them? So how will you find the maximum minimum of fx? Okay, so let's forget minimum, let's just focus on maximum. Okay, find max of x. So with this, x is actually a function in C. right? So let's see. Right now, what we did was a little bit of, just ad hoc thing. That yeah. So we looked at the. I suppose you can also always do that ad hoc thing, right? So what you can do from here is you get, okay, C is bigger than, but that's the problem. You won't always get that, right? Sometimes you'll get C is bigger than something, and sometimes you'll get the C is lesser than something. So 1 second. That is just a minute. I think it is easy, so we'll just have to, yeah. So let us say, let us try to see. I mean, so let's imagine that, um, let's imagine that we get that C is bigger than some positive number. Okay, positive number 1, and C is bigger than some positive number 2. Right? If you end up with this situation, then how would you find the maximum of C? Yeah, let's say that you ended up with something like this, bigger than equal to 10, bigger than equal to 20. Then how would you find the maximum of F? Well, the maximum will then be just infinity, right?
Yes.
And that can happen, right? For example, if these were negative coefficients, then the larger you make C, the better it is, right? There is no problem. Yeah, like so A is positive and B is positive, but then minus A and minus B are negative. So you understand, right? So you can make C as big as you want. So those things can happen. And other cases you can just systematically treat. The point is that this is a systematic question. This can be systematically solved. Okay. I'm not going into the other cases, but you can understand sometimes you will get that it is less than some positive number, right? Because if it's greater than some negative number, I mean, yeah, so then also it's not a problem. For example, if it was minus 20, it doesn't really matter, right? You can still say it's, yeah, infinity. But if it is less than this, so then also you can, so how should you do? So if it is, let's focus on this particular case. It was less than 20 and 10. So then also it's trivial, right? So in all the cases, it is trivial. That is my point. Okay, like then you know that it is this that you have to really think of when you want to look at the maximum. Okay, and similarly, if there's a negative sign here, you can again, you would know what to look at. So, and if there are many things like this, let's say 100 and some other bounds, you would know which bounds to pick. You won't have to use all of them. Okay, and then you can solve the problem. Yeah, so this did not turn out to be the way I was thinking, but anyways, this is like this. Okay. So anyways, yeah, let's move on. Let's try the next question. So yeah, let's actually, I took a long time. Maybe we'll solve one more question and today and also discuss some theory there. So Aparna, you'll be asking the next question. Yeah, on the other side. And yes. Nagesh, have you solved any NMTC paper? You have not, like you have been missing the classes. So I don't, yeah.
I have 1 or 2 questions from 2019.
2019 paper. Okay, let's see if we can get there. So Aparna will ask the next one, and then so I'm just going to end the meeting now.